Hi, I'm Oshadi and here I'm going to present you about an important topic which is DevSecOps. First, let's go through the agenda. As you can see, here are the topics we are going to discuss. What is DevOps? What is DevSecOps? Why do we need DevSecOps? How can we bring security into DevOps? Benefits of DevSecOps, DevSecOps methodology, typical DevSecOps workflow, real-life DevOps security challenges, 9 key elements for successful DevSecOps implementations, DevSecOps for cloud native with Aqua Security, DevSecOps tools. Before moving on to DevSecOps, first let's see what is DevOps means. DevOps, it's coming from two words, Dev and Ops. DevOps is a combination of development and operations. The exact DevOps is not a tool, not a software, not a programming language that you can learn and call as a DevOps engineer. DevOps is actually a philosophy or a mindset. How you take the product or app or the website you are designing and taking your website or product so that millions of people can use it. This entire process has variety of ways that you can go through with. It is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity with evolving and improving products at a faster pace than organizations using traditional software development and infrastructure management process. This speed enables organizations to better serve their customers and compete more effectively in the market. Okay, next let's see what is DevSecOps is. DevSecOps is the philosophy of integrating security practices within the DevOps process. It involves creating a security as code culture with ongoing flexible collaboration between release engineers and security teams. DevSecOps is a natural and necessary response to the bottleneck effect of older security models on the modern continuous delivery pipeline. The goal is to bridge traditional gaps between IT and security while ensuring fast, safe delivery of code. On the other hand, it's aware of approaching IT security with an everyone is responsible for security mindset. It involves injecting security practices into an organization's DevOps pipeline. The goal is to incorporate security into all stages of the software development workflow. DevSecOps ensures not to save security for the final stage of the software development lifecycle. Why do we need DevSecOps? Here are 4 reasons to why we need DevSecOps. First one is DevOps moves at rapid pace, so the traditional security just can't keep up. Second one is DevSecOps makes it easier to manage rapid pace of development and large-scale secure developments. Third one is DevSecOps allows for much smoother scaling of process. And the last one is security as part of process is the only way to ensure safety. How can we bring security into DevOps? Tightly integrate security tools and processes throughout the DevOps pipeline. Or automate core security tasks by embedding security controls early on in the software development lifecycle. And also we can do continuous monitoring and remediation of security defects across the application lifecycle, including development and maintenance. Okay, now let's move on to benefits of DevSecOps. First one is faster delivery. The speed of software delivery is improved when security is integrated in the pipeline. Bugs are identified and fixed before deployment, allowing developers to focus on shipping features. Second one is improved security posture. Security is a feature from the design phase onwards. A shared responsibility model ensures security is tightly integrated from building, deploying to securing production workloads. Third one is reduced costs. Identifying vulnerabilities and bugs before deploying results in an exponential reduction in risk and operational cost. Fourth one is enhancing the value of DevOps. Improving overall security posture as a culture of shared responsibility is created by the integration of security practices into DevOps. And the fifth one is improving security integration and pace. Cost and time of secure software delivery is reduced through eliminating the need to retrofit security controls post-development. And the last one is enabling greater overall business success. Greater trust in the security of developed software and embracing new technologies enable enhanced revenue growth and expanded business offerings. DevSecOps methodologies. There are several DevSecOps approaches implemented by different organizations. Here we will see the DevSecOps guide introduced by Aqua. After understanding the value of a DevOps mindset, making the cultural shift and reaping the benefits, many companies are aiming for the next big step, integrating development, operations, and security into one organization. However, DevOps programs are ambitious and challenging to carry out. Organizations need to manage their resources, tools, cultural and structural changes. The guide by Aqua explains how DevSecOps programs are implemented in organizations of all sizes and in different verticals, discusses real-life challenges faced by organizations making the transition, and provides stories and lessons you can learn from those organizations. The methodologies in DevSecOps guide proposed by Aqua will help any organization to take a big step towards successful implementation of DevSecOps. Okay, now let's move on to typical DevSecOps workflow. As discussed in DevSecOps guide by Aqua, here is the typical DevSecOps workflow. First one is commit. Commit is a developer creates code in a repository and commits their changes. Second one is analyze. That means another developer pulls the code from version control and performs. And then set up environment. If the code passes static analysis, an environment automatically spins up, deployed in containers with configuration managed by infrastructure as code tools. Fourth one is test. The build system executes a test suite, including unit tests, functional tests, UI automation tests, integration tests, and security tests. And fifth one is deploy. If all the tests pass, the new version is promoted to a production environment. And next comes monitor. Monitor means the new production version is monitored to identify security threats. The last one is repeat. Upon identification of a security issue requiring changes to the software or any other bug or feature request, a developer creates a new version of the code and commits it to the repository, and then restarting the cycle. Real-life DevOps security challenges. DevOps teams that attempt to take ownership of security and make the transition to DevSecOps find it a complex and risky undertaking. Here are a few of the obstacles standing in the way of many DevSecOps transitions and what you can do about them according to the guidance of Aqua. First one is the skills gap. Most engineers and operations experts aren't experts in security, and security analytics have limited undertaking of development processes, tools, and trade-offs. In a DevSecOps organization, complementing each of these groups with the opposite skills has tremendous value. Developers understand security best practices and can start implementing them in every task. Security teams can make more informed suggestions, understanding the implications of specific changes to the software or the environment. Second one is serverless security issues. Serverless architecture, also called function as a service, allows to execute and scale business logic without worrying about the runtime environment, storage, and operating system. The serverless provider is responsible for the security of cloud infrastructure components, which reduces the security burden placed on the user but doesn't eliminate it. Your security priorities will need to shift to risks such as unsecured serverless deployment configuration, unsecured storage, overprivileged function permissions and roles, inadequate function monitoring, denial of service, that means DOS, and financial resource exhaustion by hijacking your own workloads for nefarious purpose. Example, mining for cryptocurrency. Third one is container security risks. Containers facilitate consistent deployment of applications, but they raise some new security challenges. Transient containers and microservices are difficult to monitor, while misconfiguration of container networking can leave your production environment vulnerable. Containers are often used to break down applications into microservices, which increases data traffic. Traditional server security solutions don't support containers. Consider specialized security technology that can lock down containers with safe configuration. Scan images to ensure they are safe, and monitor containers in production. Aqua's cloud-native security platform is one such solution. And the next one is cloud deployment risks. DevOps relies on cloud technology to automate and scale dev or test or production workflows. However, the cloud raises new security challenges, including cloud account hijacking, misconfiguration of cloud resources, which can be dangerous if those resources are exposed to the internet, privilege account abuse, which can lead to massive data loss, and insecure or compromised APIs, which are the basis of all cloud integrations. And the last one is legacy application security risks. Security administrators often overlook legacy systems, allowing vulnerabilities to go unchecked. Legacy systems are prone to vulnerabilities and patches must be continuously applied, but in some cases, updated might break the legacy system. The presence of legacy applications can disrupt DevSecOps programs. Legacy apps can create security threats, but they are difficult to adapt to an automated DevSecOps cycle. 9 key elements for successful DevSecOps implementations. Overcoming the above-mentioned key challenges is so important for an organization. For that, Aqua has proposed 9 best practices in your DevSecOps project. First one is integrate automated testing into the pipeline. This means integrate security testing into the build and deployment process. Test the security of your infrastructure in real time or as close as it is possible. To save time, you can automate simple security tests. For example, vulnerability scans. You can use automated acceptance tests known as functional security tests to verify that features like authentication and logout are working properly. You should choose a testing framework that integrates easily with your CI/CD server and that your development, security, and ops team can use comfortably. Second key point is integrate security testing into workflows. There are several types of security testing you can build into your development process. This includes code analysis tools like Veracode, which can find vulnerabilities in your code, and in open source libraries, cloud security tools like Microsoft Azure Advisor, which can advise you on cloud security best practices, and tool for securing container and serverless workloads alike. And the third best practice is automated deployment. Automation is crucial to continuous delivery workflows. Create a deployment model to manage and orchestrate deployment activities, control vulnerability, and reduce errors. Be faithful to the principle that security should happen before deployment, not after. Build security checks and security lockdowns into your deployment process, making it impossible to deploy an unsecured environment. The next point is infrastructure as code. As you can use infrastructure as code alongside continuous delivery to manage infrastructure such as virtual machines and networks. Leverage infrastructure as code to control and test installation and deployment processes and ensure they are in line with security practices. Security and ops staff should review and approve configuration flows. And the next point is continuous monitoring. Tracking systems in production can contribute to all sides of the DevSecOps triangle. Monitoring can identify security issues and help you resolve them early to prevent incidents in production. Continuous proactive monitoring helps you improve user experience in production while avoiding expensive rollbacks. Monitoring can also assist development by including integration and acceptance tests to ensure the application works as intended while it is running in production. And the next best practice is immutable infrastructure provisioning. Immutable infrastructure, like containers, are servers that you don't modify after deployment, as opposed to traditional mutable infrastructure in which you continuously modify servers. Immutable infrastructure is more consistent, reliable, and predictable and makes deployment simpler. If you need to fix or update something, you can build new servers to replace the old one, which are then decommissioned. This mitigates issues like snowflake servers and configuration drift. And the next point is remediating application security vulnerabilities. Important to have clear remediation plans that you can deploy immediately to eliminate vulnerabilities. When using open source software, integrate automated open source management tools to keep you up to date with known vulnerabilities and calculate the associated security risk. These tools cross-reference components with an updated database and list vulnerabilities according to priority. Remediate vulnerabilities fast by applying quick temporary fixes, virtual patching solutions, patching software components, modify configuration, and using runtime defensive technologies like firewalls or runtime application self-protection. And the next one is train engineers in secure DevOps. Security awareness training ensures that the development team is familiar with industry standards and can identify, assess, and respond to security issues. Training provides employees with a better understanding of their responsibilities, improves their confidence and performance, and reduces the risk of a breach. A training program can also help foster team cooperation and consistency. The last point is use secret management tools. Secret embedded in source code and found throughout the DevOps pipeline present a significant security risk. Secrets can be passwords, credentials, tokens, or keys, and DevOps teams must use tools that securely manage and store secrets. They should also implement access control that don't affect the automated workflows of DevOps. DevSecOps for Cloud Native with Aqua Security. Aqua Security lets enterprises secure their cloud native and container-based applications from development through to production. This is helping bridge the gap between DevOps and IT security and is driving container adoption. Aqua's container security platform offers transparent, automated security, including full visibility into container activity. Organizations can use this platform to find and prevent malicious activity and attacks. Aqua's platform also helps organizations implement security policies and simplifies regulatory compliance. Organizations can use Aqua to automate the secure development and deployment of applications in their DevSecOps pipelines. With Aqua, organizations can embed comprehensive security testing and effective policy-driven controls early in the development life cycle. The process is fully automated, supporting a shift-left strategy. How Aqua accelerate applications delivery and remove obstacles in DevSecOps program. First point is image and function scanning. Scans container images and serverless functions for embedded secrets, known vulnerabilities, and malware licensing issues and configuration problems. Second one is continuous image assurance. Stop unapproved functions and images from being deployed in your environment. It prevents image sprawl and rogue deployments and preempt operational errors. Third one is CI/CD integration. Natively integrates with Azure DevOps, Jenkins, Bamboo, TeamCity, GitLab, and most other tools in the DevOps toolset. Aqua scans images as they are developed and gives actionable feedback to developers within their IDEs. And the last one is collaborative remediation. Provides real-time actionable information of configuration, remediation, and vulnerability, giving feedback to developers within their CI/CD tools as a ticket in Jira or sent via Slack. Finally, let's discuss some of the tools used in DevSecOps. Here you can see several DevSecOps tools that can help you to implement a security as code culture within your organization. One is SonarQube. SonarQube is an open source platform that manages code quality through continuous inspection. The tool supports over 25 programming languages and integrates with your existing workflow. SonarQube shows the health of an application along with highlighting any new issues. This allows users to quickly detect code errors and fix them, which improves the code quality overall. And another tool is Veracode. Veracode is a DevSecOps tool that allows teams to build and deliver secured applications in a holistic and scalable way. The tool provides visibility into the status of an application across all testing types and integrates with existing tools. Veracode contains automated security tools that helps users to quickly and easily remediate software errors. This helps teams to detect flaws early in their process without adding any unnecessary and costly steps. Likewise, checkmarks, threat modeler, and Immunio are some of the examples for DevSecOps tools. So, we have discussed important facts of DevSecOps and a methodology proposed by Aqua as well. Hope this will help, and thank you very much for watching. Thank you.